ערב טוב לכולם, שמחים שבאתם ואנחנו שמחים גם לארח אתכם פה במשרד שלנו, של SimilarWeb. לי קוראים אלון, אני אחראי על האירועים ופיתוח הקהילה שמאחורי עולמות ה-R&D של SimilarWeb. שמחים לארח פה את ורדה. נספר לכם פה בקצרה בעצם על ה-POC שעשינו איתם, אנחנו נתחיל בעידו, דוד יעבור לספר לצד שלהם, ואז יש לנו בעצם איזשהו פאנל. המיטאפ, כל השיחות יעשו בעצם באנגלית, גם כי אנחנו מקליטים וגם לטובת דוברי אנגלית שיושבים פה בקהל. זהו, אנחנו שמחים שבאתם, בחרתם פיצה ובירה על פני הנייטרן, היינו קצת, לדעתי זו הבחירה הטובה. אם לרוץ, אז לרוץ, אם לרוץ, אז לרוץ בבוקר. טוב, אז ורדה, SimilarWeb, אורי פה יספר לכם קצת על ורדה ומשם נמשיך. רק חשוב להגיד, אם יש לכם שאלות, תרשמו אותם, ובעצם בפאנל נענה על השאלות שלכם.
מעולה. אז שוב תודה לכולם שבחרתם להגיע לפה. קצת housekeeping, אני אתחיל בעברית רק להגיד את זה. ערן ואנונו, ה-CEO שלנו, מתנצל, אבל היה מקרה חירום לצערנו רפואי, שהוא נאלץ להיעדר. מחשבותינו איתו, ואנחנו נמשיך. So now I will switch to English. It'll be amazing. So my name is Ori Reshef. I'm the VP product for Varada. I've been in and around the data and data analytics for the last 15 years of my life. And I wanted to share with you a story, a personal story that happened to me 10 years ago and taught me a good lesson on how to respect data and what are the consequences, the business consequences of big data. So it was 2008, I worked for Nice Systems, and we had a very, very tight head-to-head with a competitor in a large Spanish bank, a very big one. And the thing was that the data on which we needed to do the analytics sat in a data center 14 kilometers from where we sat and needed to run the analytics. The size of the data was 16 gigs. Now, all of you here are laughing because 16 gigs is something that we're like drinking in a second or a minute. But then we had to transfer 14 kilometers of 16 gigs from one place to another to start work. That took actually 3 days. And we all went crazy in waiting for the data. And even worse, we had amazing pressure from the business side looking at us like a bunch of retards that cannot even, start the POC on time. We said we'll start on Monday. Monday came and went. Tuesday, Wednesday, still no data, still no work, was incomprehensible for the business side. They didn't get it. How can you guys, so techie, you have like 5 engineers in the team, cannot grab the data? I actually tried to negotiate with the bank to go with a hard drive to the data center. They almost shot me. And they just told me, shut up and look at your screen, which I did. But that taught us a very important lesson. Big data, the size of the data is a part of the problem, a part of the engineering problem. The start of big data analytics and actually being able to work with big data is Google's white paper in 2004, which introduced to the world MapReduce and completely changed the landscape and enabled all of us to do the amazing things we're doing on petabyte scale today. I think that I'll be bold for a second. What we think in Varada we did is, if Google created the first revolution in 2004 and enabled big data, what you're going to see today enabled sub-second queries on a petabyte scale on real big data. And that's a part of the new revolution and accelerating big data, enabling big data, and even going further in the democratization of big data. So you'll hear today, you'll hear in details from David about Varada and what we do. We'll go into the technical details. It's great to see familiar faces and a lot of technical talent here in the audience. But first, we'll start with Ido that actually dealt with this big data problem, and we'll hear the thinking and how to solve real production problems of real data coming from the business side. Again, if I go back to the story, there is always a business need that will push us in the technology to actually deliver analytics on big data. So I'm honored to invite Ido Senesh to the stage to discuss and to show us how they started to think about analytics in big data.
Hello. So I'm Ido from SimilarWeb. I have very good English, so if you have questions later, you might didn't understand me, so just come later and I'll help you with Hebrew. So I'm a backend engineer in SimilarWeb. In SimilarWeb, we deal with a lot of data. So this slideshow is about our journey in a very specific use case, very interesting use case in my perspective. First of all, let's start with who are we? So SimilarWeb is a market intelligence platform. We give data and insights on all the digital aspects of the world. We give data about websites, apps, industries, and we are actually the go-to-market tool for investors, advertisers, marketeers, and so on. We work globally. We have over than 190 countries, and that's a lot of data, okay? So a little bit about our data. So we have data that comes from a global panel data, a very large amount of users that give us anonymized data, global ISPs data, public data sources that are available to everyone. We take this whole bunch of data, we combine it, we use machine learning and all the buzzwords to make predictions and machine learning and to actually bring insights to our users on our Pro platform, on our APIs, and on different services that we provide to our users. So this is a bunch of some of our customers. You might know some of them, you might not, but just imagine that they use our product. Okay, we need to give a very good insights and great data so they will continue to use us. So take it on mind when you decide whether to use us or not. Okay, so let's start with the technical challenge. So this is the keywords group use case. You pick a lot of keywords. In my case, my interest is in blockchain, but pick whatever you like. You pick a lot of keywords, up to 200 keywords from some industry that you find interesting. And after picking them, you get this view of up to 10,000 websites, which basically means when users pick these keywords, what sites they are referred to, okay? So for instance, on our case, apparently CoinMarketCap is the main website that is being referred by these keywords. One important thing to see is that we have data both from our panel. This data is the traffic share, okay? How many users came to each website. We have also data that is coming from other table of the public resources data. For instance, the position on search engines. Okay, this data could be queried for up to 36 months, okay? And one important thing to notice is that each keyword may lead to up to 10,000 of websites, okay? So let's say if you pick shopping, shopping may lead to eBay, Amazon, AliExpress, and a lot of other websites that I can't remember right now. Another thing to understand about our use case is that nowadays, before this POC has started, our main approach of tackling this use case was bringing all the data to our servers to our Pro servers, aggregate them, filter them, combine them, and after all this work and process is done, we limit the results to 10,000 results, okay? So just to understand the amounts of data, we'll have the next slide. But this is some flow of a regular user. He picks 200 keywords. Let's say that he picks 12 months analysis. And what happens after this is this amount of requests, 400, 800, get operations for HBase. This is the current database that we use. And you can see how much rows it may yield, okay? Each keyword brings 10,000 results. And it sums up to pretty much a lot of data, okay? We have very strong servers with very high amounts of CPU and memory in order to provide the deserialization and the grouping and all this job that needs to be done. At the end, our happy user will only get this amount of results, okay? So it feels like too much work for too little data. And this is one of the reasons that we have started this very interesting POC. So just some numbers that we could just understand the amounts of data. Our old platform that supported only 200 keywords had dealt with this amount of data per one request, okay? This is our database that is related to the two different tables. And to bring data on one request, we needed to process this amount of gigabytes, okay? So why did we start this POC? So one of our very large customers asked for this feature, okay? His users are using a lot of keywords. He wanted much more than 200. And if we'll look back, for 200 keywords, this is the amount of data that we need. So what will happen if we use this amount? It's about 35 gigabytes, okay? It's a lot of data. Imagine just inserting one request to our server. It will be very inefficient. We'll have to have a very large machines. And this is why we have started this process. Okay, so let's start with the POC requirements. We wanted to test even more extreme cases because other users wanted even more data. So the amount of keywords that we wanted to check is 20,000, right? 20K, let's say K instead of thousands. 20K keywords. We wanted to test it on the top search keywords, okay? We doesn't want to use edge cases where everything behaves as expected and with low latency. We want to push the system to its limits. We want to push down as much calculations as possible, okay? We want our database to handle most of the data. In a perfect case, we would like to get the 10,000 keywords into our servers and nothing more than that. We want fast response times. Now, when I'm saying fast response times, we will later see the response times before, okay? So for us, it will be a couple of seconds, maybe in extreme cases, maybe a dozen, 10 or 20 seconds, but not minutes or so on. Another thing that we wanted to set as a requirement is simple bulk data loading. We had other problems in other solutions that was related to this one. I'll elaborate it on later. But these are our requirements, and this is how we started this journey. So first of all, when a client wants a very extreme feature, you do it because you want this client to remain your client. So after very heavy server-side optimizations on the serializations issues, reading streams, many other different things that we have done, like pre-calculating things as much as early as possible, we have came to these results. We were succeeded on doing 5K keywords on 18 months in about 50 seconds, okay? So we know this is not optimal, and we wanted to test new technologies that might help us achieve very larger magnitude of success. So first of all, our state of mind was, let's keep our data the same and just try other technologies. Druid and REST-based are two solutions. Druid is a solution that everyone knows, I guess. It's a database that is publicly known. REST-based is some layer that we have created in here in SimilarWeb that help us query HBase with SQL. And after trying working with this setup, we came to the conclusion that we must change our data. We can't join huge tables without having the cost of the performance. So our second step was combining the entire data set that we have into one single table that allows us to query instead of joins, allows us to filter directly on this table. After doing it and writing the data to HBase, what we have tried to do was using Phoenix on HBase. Phoenix is an SQL engine that allows you to write SQL, and it translates your query into HBase operations. It sounded pretty good, but one of the problems was bulk data loading, because Phoenix allows only CSV bulk loading, at least at that time. I'm not sure today. And we had a lot of exceptions and error and issues because our data is very dirty, okay? You can imagine each and every single character that you imagine will be in some sort of keyword set, okay? Another issue with Phoenix on HBase was the splitting problem. In order to provide good performance, splits must be calculated before you create the table. Because we wanted to use one table that combines the entire data set, when we bulk loaded data, the performance was very much degraded, and we had a lot of issues on calculating the splits and making it work with good latency. At the end, we didn't continue with this solution. So each and every one of these solutions had some drawbacks, issues that we encountered. And after Einat have met Varada, we've started a new POC. And the POC with Varada was very interesting. I met them, my first meeting was with David and Roman. We described the use case, and our first homework assignment was to combine the new data sets, to query the new data sets with SQL. Okay, HBase is, you get each and every key. We've created a new SQL that combines the data in the way that we want. And we wanted to bulk load the data into Varada's system. The problem that we had, and as I mentioned before, we had it also with Druid and with HBase, was that Varada was bulk loading CSV files. And as I already mentioned, the encoding issues, the commas, the different characters, it caused us a lot of problems with Varada as well. After several meetings, we decided to move on a new solution, moving to Parquets. Parquets, if you don't know the file type, is a standard. It's structured. The files are structured, and from this point, we had a lot of we had much better life than before. The dirty data was now not a factor because the data is structured. It required from our side only several changes on our Spark job. And from Varada's side, I believe it demanded a little bit more development time. But, but at the end, we got a system that allows bulk loading of Parquet files. We enjoyed the built-in compression when I sent them the huge amount of data on S3. And another nice bonus was smooth portability to other systems. For instance, we used Athena to validate the results that we got from Varada. So it was very nice feature request, I believe. Okay, so the second large challenge that we encountered was actually here. This is a sketch of our SQL. As you can see, it has a lot of summation, aggregations, window functions, and stuff. Everything was translated successfully to Varada side. But here you have someone that is pretty suspicious, okay? The keywords. We usually think of queries as just a small, short string that contains some very basic thing, but when we move to a huge table instead of 2 joins, we now got a query that contains 20K keywords, okay? So you could just imagine the amount of text that each of these queries was look like. So from our side, no transformation was needed because we had no option. We want these words, okay? But Varada added a very nice feature of query compression so that this query, when it's sent to different workers, it's first of all compressed. Keywords are pretty compressible because these are keywords. They are not random numbers or something. And after this very small from our side addition, we got 2 times faster queries, okay? So some results, because this is the interesting part. I remind you that before we had 5K keywords on 18 months, and it's taken about 50 minutes plus minus. 50 seconds. No, 50 minutes I wouldn't stand here if it was. So these are the results of the POC. I've just taken several metrics that are interesting. So let's see, for instance, the 20K keywords, okay? The top keywords only are the most extensive. I don't know if extensive is the word, but the keyword that returns the larger amount of results from our data, okay? Keywords like Amazon or games or whatever, or shopping. Real world keywords are real world keywords, okay? Usually you are not interested on the top keywords, you're interested in keywords on your industry. So this is the difference between these 2 columns. And you can see in the results, first of all, in the top keywords, that on 20K keywords, we got 28 seconds, okay? So it's about 4 times the data that we used to process before. And now we don't actually do anything on our side. So our server could be much less powerful and it will still work as expected. And another interesting thing is to see the real world keywords. Okay, this is the use cases that will probably be interesting to our users. So this place means that normal user will be able to use 20K keywords of his own, and he will probably get results in about 10, 12 seconds, something like that. I don't think that we ever reached this number on our previous test because 1 minute was our top limit that we allowed to queries to run. So these are great numbers for us. Another nice experiment that we have done was 50K keywords. So this one is a mixture of 5K top keywords only and 45K real keywords from real usage of users. So you can see that the number here is 38 seconds. It's still better than our first server-side based solution. So it was also very interesting and very nice to see. We also wanted to test performance while bulk loading, okay? One of our problems, what I mentioned about splits, was that when you create new data, when you append new data to your table, the performance is really degraded because of the new split rebalancing. I don't know if this is the right terminology. But here, Varada provides us with a solution that allows us to pick how much we want to invest in the bulk loading process and how much in the query process. And as far as I know, it's now zero cost to bulk load data. So things changed since this POC taken place. We also tested for parallelism. We tried 20 concurrent users. The performance there was a little bit harder to be. It was about 4 times the times that we have encountered in single usage. It's important to notice that on our platform, it's very rare for more than 1 or 2 users to use this extreme case. I mean, it's very rare use case, and we have caches. So only the first hit is actually hurting us. So in general, it was great to work with the Varada guys. We are looking for your, I don't know. Yeah, exactly, GA version. Coming up soon on the market, on Play Store. So thank you very much, guys.